Okay, in this video we will be seeing the PWM practical session. So this application is pwm.c, and this is used to control the LED brightness using PWM interface via sysfs. Okay, so these are the required header files needed for this program, and as mentioned in the theory class, so sys class PWM and PWM chip 0, we are exporting the PWM1 by writing 1 into that export file, and then PWM period, this is the path for that period file, and this is the enable path for this PWM, and this is the duty cycle path where we will be able to control the duty cycle. So here instead of a dot out, we will be giving it as PWM underscore rugged board. Okay. So how we will be giving the how we will be executing this file is, this is the executable file we will be generating, and this is the period we are passing it as an argument 1, and duty cycle as the argument 2. So here this is where our entry point of our code. This is the required variable where we will be using it, and we are creating an memory of 4 bytes in the heap segment for value underscore string. So now we are opening that export path. Export path is nothing but this. So where we will be exporting the PWM1. Why? In the sense PWM1 is connected with the microbus. It is connected with the microbus of the rugged board. So we are using the PWM in the microbus. So we are opening that. I mean we are exporting that path, exporting that PWM in that PWM chip 0. So once after exported, we are going and writing the periods. So this is where that we will be getting it through the command line argument that has been written by using this write system call, and then we will be enable the PWM1 by opening that PWM enable file path, and by writing 1 into that file we will be enable that PWM. We will be enabling the PWM. So since the period in the command line we will be getting it as string, we are converting that period into an integer, and likewise the duty cycle also we are converting into an integer and putting inside the value, and we are opening the duty cycle the path, I mean the duty cycle, this file we are opening it through this open system call, and that is in a write only mode, and we are moving into the infinite loop, and we are using the sprintf, and we are putting the value inside this value string, and we are writing that duty cycle inside that file descriptor. Once we have written the duty cycle inside that file descriptor, now we go on increment that duty cycle. We will go on increment the duty cycle, and it is sleeping for 100,000 microsecond, is equal to 0.1 seconds. Okay. Now we are checking for if the value is greater than or equal to period, where the period is nothing but our 100. So if the value is greater than the 100, and again we are making the value, and again we go there and putting that value inside it, and again we are going and writing it. So likewise we will be able to control the brightness of the LED. So this we will be seeing. Let us compile the thing, and we will be seeing it, looking into it. So first we are compiling it and copying it to the TFTP boot. So then I will be pulling that file from the TFTP boot to the rugged board by using a TFTP protocol, and then making it as giving the permission for that PWM RB as an executable permission, and let me try to execute it. So I'm giving the period as 100 and 0.5 as the duty cycle. So let me run it. So now you will be able to see that the brightness of the LED is getting decreased. So it is getting decreased, and it is fully off. Then again it will be having full brightness, and it is decreasing. So and again it will go to the full off, and then again it starts from the first. So likewise it goes on decreasing the brightness, and again it get increased. So in this way we are able to control the brightness of the LED using PWM in the rugged board.